question, we've been given a box and whisker plot, and we've been told that it summarizes the weight in grams of 20 chocolates in a box. The first thing we're asked to do is to find the interquartile range of the data and to determine whether there's any outliers at either end of the distribution. So it seems like this box plot has been produced without considering if there are outliers. So let's make sure we do that step. From the box plot, we can tell that the lower quartile is 17.8. The upper quartile is 18.1. That means the interquartile range, the difference between these, is going to be 0.3. Where do we look for outliers? Our boundaries are Q1 minus 1.5 times your interquartile range and Q3 plus 1.5 times the interquartile range. Let's put those numbers in, 17.35 and 18.55. Anything below 17.35 or anything above 18.55 will be an outlier. Looking at the diagram, the lower whisker is not below 17.35. So there is no outlier down here at the bottom end. At the top end, however, the upper whisker is 18.6, where my boundary was 18.55. So that value at 18.6 is an outlier, and there may well be more values above 18.55, below 18.6. All of those would be outliers. So our comment is that there may well be, or there is at least one outlier at the top end. The second part of the question tells us that Ben buys a box of chocolates each weekend. The chocolates all look the same on the outside, but we know 7 of them have orange centers, 6 have cherry centers, 4 have coffee centers, and 3 have lemon centers. One weekend, each of Ben's 3 children eat one of the chocolates chosen at random. We're asked to calculate the following events. Okay, firstly, just quickly to summarize in my working out, what distribution of chocolates do we have? 7 for the orange, 6 for the cherry, 4 for the coffee, and 3 for the lemon. We're asked to find the probability that all 3 chocolates have orange centers. So that would be orange, followed by orange, followed by orange. Rather than a huge tree diagram, which have lots of branches, 64 in total, we can just go ahead and think about the probabilities that would be on those branches. So probability of orange, 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 well, that's 7 out of 20, and then I have 6 out of 19, and then 5 left out of 18. That gives us 7 over 228. So that's the probability that all 3 of them have orange centers. Part B asks us to find the probability that all 3 have the same centers. So orange, orange, orange is all having the same centers, but there are other combinations which also have the same centers. We could have cherry, cherry, cherry. We could have coffee, coffee, coffee. And we could have lemon, lemon, lemon. Let's find the probability of all of these as well. 6 times 5 times 4. And if you notice in the denominator, we always have the same product. 4 times 3 times 2 for the coffee, and 3 times 2 times 1 for the lemon. Okay, each of these are going to have the same denominator, 6,840. The numerators are 120, 24, and 6. Because I've kept them all the same denominator, I can quickly add these together. 210, 120, 24, and 6 gives us 360 over 6,840, and that simplifies to 1 over 19. So the probability of event A, 7 over 228, and the probability of event B, well, that's going to be 1 over 19.